Okay, seems like I'm live. Okay, so hello everyone. Second session of work. Should have streamed a bit earlier this week, but I got like very busy with some work. I did some progress on the last VFX we worked on. I also built the spell system I was trying to build, but I knew it was going to be a bit tough to build it in like an hour or two. So I just built it on my own in a very chill way while watching the World Cup. Okay, so if you remember the VFX from last time, it was like this reference from BlazBlue. And I managed to get something pretty decent. I also changed a bit the glitch. Like I made another one with like texture offset, another one with like flipbook based, and one that's like entirely shader based. And then I started to work on like this sci-fi HUD, the ones that you can pull with like the free plugin of like Niagara widgets. Maybe I'll cover this up in a later video. Later, when I have the time. I've been incredibly busy recently. I'm gonna show you the blueprint I was working on, and I was talking about just earlier. Okay, I hope I didn't break anything and that everything is working perfectly. So I've made, so these are like placeholders, right? But I've made them so, you know, it's easy to plug and play. I have these array explosions that can trigger row by row or index by index. I made it like a MOBA type of effects. You know, it's like League of Legends where you have like projectiles on one key and like other like fast cast spells on another one. You know, and this is like fast cast. So I just select the location and then it plays the VFX at the location. Simple. And then I made like this AOE one where you know it rains like projectile from a location and display like the heat effect on the ground. So it's actually very easy to use. I can determine how many of them, like it's made in a way to determine how many projectiles are being displayed, kind of, and how many of them are falling, which is quite helpful. If we had to add like a damage hitbox or a damage container, kind of, we would just need to just like plug it already, and it will be attached to that projectile. Because the way I build it, so let me show you a bit how it's made. Yeah. So the way it works is we have the container and the AOE spell rain. So if I want to, I can have like the rain spawn elsewhere. I can have as many containers as I need, and it should be fine, you know. And if I need to make a modification on the gameplay, everything is in the container, and the AOE rain is just gonna be, you know, the trigger basically. Let's go into it a bit and check how it's made. So in the beginning, we have wait, I don't even remember where I put the... we have our master spell basically, which is just like a container that's gonna hold all our class defaults. Target location, start direction, aim direction, if it's needed, you know. Then that's it. We have like a blueprint interface that's gonna trigger the cast spell, and basically it's gonna cast the spell we want to have. Everything is left empty on the parent because it's just like the blueprint parent that's gonna hold everything if we ever need to. So if we need to add stuff on all of them, we just add it here, and then it just like simplifies everything. It just streamlines the process. Then you see these ones like single drop, single projectile, simple cast, spell array. These are like the child actor, and it's basically holding the logic for the spell. So each of them have like very different integration. So for example, let's check. I think the math I placed it here. Yeah. So for example, for the array, I will hold, and for any other spells that I've built, I will build the logic in the function. And this function I will call, and this will execute the spell right after. So any logic is built in the function, which is then triggered in the execute spell, and which then calls the cast spell, and it makes it so at any part of the spell I can control either in the call of the spell, so when it spawns, or when it's playing, or when there's an impact. So if I want to add sound, for example, I will be able to add sound at any level. And if I need to add like some triggers or like gameplay elements, it should be possible. Maybe there's going to be some bugs, of course, that I will have to fix. But it should be able to, for example, trigger like a damage, or like trigger a collision on like a character, or anything that's like related. So for example, when I was talking about a function that was like determining like the behavior of the spell, this is like the build points for the array. So the way it works, because this is a bit big, but I made it so on one side we have, I always like to talk about it, you know the Cartesian coordinate and the polar coordinate. You know, I like to use them because basically you can transform forward direction in like a radial one, and I always like to use this. You know, I find this math very fancy every time, and it's very fun to use. So any array that I project forward, I can also project it radially. So let me show you in the class default. I can do fancy stuff like this. So, oh yeah, I was already in class default. So if I do, if I hit play, so here it's gonna be a Cartesian coordinate, you know, up. So just the forward motion, and we can see like the display of the grid, you know, and the reticles that are on the ground, so we can see them. They get curled with distance because I'm working on like a very large scale scene. But now if I switch them to polar, it's gonna work, and it's gonna deploy like this. Or then if I want to change the orientation, I just change the line axis, and then it's gonna trigger from the center. So if we want to make a spell like you know Nautilus splash damage, the E spell, then I can build it, you know. And this is what I like to use functions, because you know we can branch them, and it's not gonna affect too much. Like it's not gonna affect the performance at all, because only one branch is gonna be executed, you know. And that makes it incredibly helpful to build spells, because if I want to do, for example, only 180 degrees, I can do it as well, and it would be in here, and we have the arc degrees, and here it's 80 degrees. But if we want, we can just like put I think 30, and it should only work in the grid. I haven't tested this feature again, so maybe I broke it or something. No, okay, it's working. Okay, so if you want to have to do half a circle or like a quarter, etc., you can just like use them and plug them. And yeah, it's very robust. And here I'm spawning, I don't know, like how much is it? 12 by 8. Oh, it's 130, 20 something. Okay, I didn't do the quick math, but yeah, it's running quite well. It's the Nuke Explosion that's playing from the back. And yeah, it's running well. It's pretty smooth. Most of the VFX, unfortunately, like if you take the VFX from the sandbox, they are all set to infinite, so it's not gonna go. It's not going to work straight away. You have to like tweak some settings, like change them so they only play once, and yeah, as soon as you have that, it should work. It should work fine. And that's the actual problem I have with the projectile is like the blueprint checks if the actor is completed, but the problem is like the Niagara doesn't clean itself up automatically unless it dies. So here it's just gonna spawn forever. But you understand the logic that yeah, we can spawn from one point to another, and that's pretty good. And then we have, for example, this one. It's not the same as the one that's from the AOE. And it's yeah, I mean it's working pretty well. So that's it for the blueprint system, like the spell system. Oh yeah, I still have like those those debugs going poop. Okay, yeah, it's when it gets destroyed and so garbage collected and everything. So I know that I had like issues where it didn't get cleaned up properly, and anytime I was spawning new ones, it was starting to lag more and more. So I fixed that up. It was a tough one to solve because I didn't know at which level of the code I needed to do it, if it was in the function. So I needed to place debugs everywhere to know what was happening, because after building it, I thought it was going to be easier because I know to make a projectile goes from A to B. But after that, it's a bit tougher to know whenever you change the behavior of the projectile at different levels, to know where it's fucking everything up. So it's been quite a productive week, I'd say, on the sandbox. And I've also worked on this part. Let's go back to the demo. Yeah, I've also worked on these parts, which is well, very straightforward. I got inspired by. Let me show you. Let's not like leak everything out of that. I was inspired by Ace Combat. I've played Ace Combat last week. It was in sales for the Steam summer sales. Okay, there's a YouTube video in here, but like ignore it. Was this one. I was inspired by this one. Pretty straightforward. When you look at it frame by frame, you see that there's several layers of structure that are holding them. And it's a pretty neat sci-fi stuff. It's pretty sweet, UI. There's a lot of like sci-fi UIs, like Metal Gear, Ace Combat, Death Stranding. Even in BlazBlue, they also have like some sci-fi-ish elements, and yeah, they look pretty polished. I kind of like that style. It's very nice. But for now, let's keep working on like this sci-fi effects and move on forward. I'm gonna be super late for the release of like these ones. So I might just end up like releasing these ones in like 2 or 3 days, and then delay these ones for like a week or two. Because yeah, I haven't started it. It was warm. It was a lot of work. It was a lot of stuff here and there. But it's moving forward slowly and surely. So what I was building right now, it's a material function for the interface. And you see when in a video game we have like some screens where like some informations are like panning and everything. That's basically what I'm building. So the idea is to have multiple regions initialized. So we get our UVs. We set a minimum and a maximum, which will determine the size or like the bounds of our UV 0 to 1. Then we get the center, and we're gonna split the channels to mask them basically. And this will allow us to like move like the each elements on the screen. And like for example, I think I made a quick painting right here. Yep, I have it right here. So it allows us to have like 1, 2, 3, 4, 5, or like as many as you want, and like control them individually, you know, and have the panning locally. So 1 is gonna pan one way, 2 can pan another way, 3 can pan another way, and 4 can rotate. It's pretty much what it will do. Yeah, I was building that so we can start building this interface. I'm working on that. Let's work on that first, and then we can work on finishing this one as well. I feel like doing some technical stuff might be more comfortable for this afternoon, and yeah, it's pretty chill to just like do notes instead of like doing some Niagara stuff live. Okay. So on the notes I have, okay, so I was masking the channels. Now what I need, it's to get the local and make it pan, because this needs to control, because we have like this panning vector 2, and that's all I need. So it works. I just also need to multiply the mask because yeah, that's required up. Because if we do some transformation in the R, we need to do them in the green channel as well. So we don't end up with like some offsetting stuff that might not look natural. Oh my god. Okay. Yes. What I need to do. I have also some notes on the on the right side, because I was like, let's make it so it's not like too boring to watch. Because I already made some kind of like material function like that before, so I'm just like cleaning it up at the same time. So we need our local position, which is this one. Local minus, oh yeah, sorry, I'm gonna local, and now I need to add it to the panning. Oh. Wait. do I need to get yeah, wait, because I don't see the I'm blocking my view with the windows you don't see. Up, up, up. I need to reorder a bit the HUD. And we are good. Okay. So now you have the panning based on the local position. Which up to local position panning. Okay. Then we need to control the size of what's inside our region. So what we're gonna do is we are gonna multiply after the panning with the size. I'm gonna create another input and get the scalar function input and do size. Tac. And then we do add. I received some questions like on by email and not by comments. So sometimes I get like a question asked like why I don't use portals, for example, because I could basically make portals everywhere. I've worked with portals in production, and like some other people are working with portals. They are very useful when you have seen the material already. But when someone new comes in, it's very tough to check left and right, even with the color coding and everything. I'd rather have like some kind of half spaghetti code than portals that are going like left, right, in the corner and everywhere, because that's almost unreadable, and I'm losing more time than if I'm just following the spaghettis. So we have the panning, we have the size, then we do we have to, if I'm correct, add it with the minimum. Yeah, mince. Mince. Up. If we add it with the minimum. Oh, wait. Oh, my bad. Yeah. Okay, and I made the size parameter, but this one is the size. Min and max is our actual size. I forgot about it. On my other material, I I made it as vector2, like vector4, sorry. And I made min and max in XY and WZ in the min and max input. So this one can also be function input. This one can also be a vector4. But then you have to remember that your RGBA channel is going to be a vector4 and not a vector2 anymore. And sometimes I forget about it. Okay, so we have the size. We have we multiply with our size. We add the minimum. I think it's not to get 0 if I'm correct on my calculation. Then we add Then now that we have our size, we should multiply with the mask. But now the question is, because on my side, I have multiply by multiply, input mask. So if I do this, no, I think I need, wait, I need to append. I'm not sure. So this is slot kinda. So if we have to take it like that, it's already a region. From here, it's already a region. We have our local position. Then we have our transform. We have the size. And we have the minimum size. So if we multiply this by the slot, we get our masked UV. I think so. I'm just trying to project in my head because basically what we have right now is like we have the center position of like our island. We have its minimum bound. And what it's trying to do, it's just by placing this, it's gonna basically place the rest. And then the mask UV is gonna be this. Oh, okay. If let's ignore this previous bound, but basically the previous UV or like the mask UV is gonna be this, if we want to. So then with the scale, we can scale it from that position, and if we want, we can just like expand it outward or expand it inward by just taking the corner of like the min and max. Because if we have the coordinates of like the minimum and the maximum, we can then scale them back towards the center because we just need to get the center position, and that's what we're doing in here. We do we get local. We want this to be positive, of course, to avoid like problems and like be offset because let's say no, well, I mean our pivot point is gonna be here, and if it's gonna be negative, it's gonna be outside. It's not gonna be in the center. So if we do 0, 5, 0, 5, we're gonna be here. If we do minus 0, 5, minus 0, 5, we're gonna be away. So I believe what I need to do, it's this. Hop. Masked UV R, and then masked UV green. We are gonna need multiple outputs because one isn't going to be enough. So we're gonna need this up back into 1, and we are gonna yeah, maybe I need to split this as well. I'll check. Let's check first if it works. Up, we should work. And we are gonna need our mask, I believe. Up. Oh. Yeah, because I have an input. Oh no, I forgot. I need an output. I put an input and that's not working. Voila. And this is gonna be our mask. And it should be, but wait, mask UV and our mask, which is gonna be. I can just reuse the same mask. Yeah, my bad. Because if I don't output, I was thinking that if I don't output the mask size, it's gonna be a problem. But I can just like get it back from the inputs. Okay, should be good. I think it should be good right now. Let's check if I can make the master now. I'm just gonna make it here for the moment. M region UV test. Okay, so let's use, I can actually do this. And do append vector, tac, 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 name them. It needs to be a parameter to be able to name them. Yeah. X, Y, wait. Oh. X mean, Y mean, X max, Y max. Okay. And now we can do this. We can have our panning up. And I think I'd rather have two of them split up. X panning, Y panning. Plug them here. Append and plug them here. Oh, it's so obnoxious to not be able to have them straight on. Oh my god. Very, very obnoxious. How can I get them to align correctly? Oh my god. My OCD triggers. Mask. Okay, so okay, I'm gonna delete it so it's up. And UVs. Okay, so now let's check up this one's. Unlit. How does it look like? Oh yeah, because I need to do 0.25, 0.25. Okay, 0.5. Then I need a mask to be. Voila. Okay, you see now what's going on here? It's like we are okay. There's a mistake somewhere. I need to fix it, but we do have our region that like squared on kind of. I just messed up somewhere. You see here? It's not like UV. There's something in the math because we should be able to see like this square as like one kind of, but we don't. Messed up the math somewhere. And panning is gonna basically make us offset it basically. Let's check. Texture coordinate. No, wait. Texture sample, sorry. Texture sample. Up. And let's have a texture quickly. Let's use one that's like visible, maybe like this. Yeah, this one. Apply. Why is it not working? They cast a float for where? What? We cast a float for this? Ah. Now we just have this one and this one. Wait, did I mess up somewhere? Am I crazy? Is that this is float? This is one. Okay. Now I multiplied. Ah, this is not one. Okay, this is vector 2 multiplied. So this is back to. That might be our issue. Didn't I forget? Okay, what else? Okay, just to quickly check because I want to see if that's broken component mask. Yep. Okay, so it's kind of working. Okay, so we have this. Okay. Now, if I do this, we scale our mask basically. We scale what's inside our mask. Now, if I do pan, I'm doing offsetting. All good. And now if I do this, I'm scaling it up. So I have a problem here. Okay. I found the problem. 0.5 and 0.5. Let's get it to the back. So we're not scaling based on the top part. So there's a problem here. So we get a UV minus min. Just gonna check. We have max, sub, min. So we get the size. Okay. UV minus min. So we get the starts of our bounds compared to the UV. And now we get our local. My bad. I think it's that. I messed up. Well, at least I know it was an issue. At least now it's fixed. Now we start the logic of our mask. So we subtract our local. So this, I'm just gonna rename it this. We subtract our local, and we subtract it by 0.5, so we get the center of our local position. Because let's assume in the UV, start at 0, 0 to 1 space. So let's assume we want to reposition that position. Then we need to subtract this position by basically half of the normalized UV. So since it's 0 and 1, if you subtract it by 0.5, we get the middle of 0 to 1. And that's logical. So this is now correct. Since we want to make sure that that value is positive, even though this should be always positive. If we have negative UV coordinates, then we want to make sure that this middle stays the same. So we do absolute values of that subtract. And that is also correct. So thanks to that, we get the absolute values of our center position, our center local position. So now, why am I subtracting it again? Okay. Okay. No, I think I'm subtracting it to get back the 0. But then I can just do this, actually. Yeah, maybe I had the bug before on my setup, and then I fixed it like that, and now it's like fixed like that. Because we want to get it back in the right. Okay, we want to get it back in the position. Or like, if the UVs are negative, because this one is always going to be positive, it's never going to change. We want to get back this 0 position from the positive value. We don't want to get it from the negative value, and that makes sense. So this is gonna be our constant minus the value absolute, the absolute value of this operation. So now we multiply it with this to get our mask as much as possible. Oh, we can't. Because there's nothing inside. Yeah. Okay, we have something. Because the UVs are empty. Wait. Let's have like let's have some values in there so we can actually see what's happening. Up. So we can see why it's fucking up. Puff and panning, we can leave it at 0. It doesn't change anything because it's only the panning value. Okay, so now. Okay. Now we see stuff. Now we see clearly what's happening. I've done that earlier. Yeah, so this just like takes our minimum bound at 0, like we said. This just gets us a flat size, basically. So this, then if we divide by that, we get the size based on this position, and then we get, we subtract it, so we get the middle. It's not in the middle. Or like, I think it's in the middle, but we just get bamboozled by a preview. This should be good, and this should be good. The saturate gets us here. Yeah, it's just this is like just to get us have non like half floats in our mask, or like not completely opaque on our mask. So we avoid not masking the correct region. So we saturate that. We mask. We component mask this. We multiply them by the scalar mask. It's basically our tiling actually. So I shouldn't call it mask, but then we add it to local position plus panning. So this is this, and this is this. So basically, it's gonna help us move the texture. We multiply it by. Wait, we add it, then we'll multiply it by size. Yeah, it's good. Then we add it. Then we add it to the min. Then we add it to the min. Min. We add it. And then we mask UV by doing this position, like this bounce, by the mask. Has anyone done that? Has anyone done that before? Okay. Oh, wait. No, yeah. Okay. I got it now. So basically, what I want to do is this. It's this. Because now we should get our mask. Wow. Incredible. You don't split it. No, that makes total sense. And now you should just plug it right there. Because this is our mask basically. And so we get the UV mask. And so we don't actually want to do this. Yeah, let's not have the input. And now we just have, we just multiply this by that. Because now we have the correct size. And now we just do this. Okay. And now we have UVs. Woo! That should be good now. Yep, that's good. But now we don't have a one-on-one region UV because we don't have this anymore. No, we don't have this, but we do pan stuff and we do mask out regions. Now the problem is if I go out of bounds, does it still stretch? Yeah, I stretch the UV, so I need to mask out some areas. Basically, here we get the corner in here, but we should be able to get it in the middle by not adding it again. Ah, no, wait. No, it's this, that's the offset. No, wait. Ah, okay. No, my bad. My bad on that. Okay, I understand now. So instead, yeah, so now if we do this, we have a 1-1 sheet. Or like, it's not a 1-1 texture, but it's like, it's still, so the texture is this size, but now we want to rescale the entire texture here, probably. So what we want to do, do I just rescale the UVs from this center position? So we get this as like the middle. I think so. Yeah, no, I think just that will work out for our thing. So if I just need to do this one, let's just make a copy of this material. I like this copy of this texture. And quickly we can do a wrap. I'm just copying this texture. So when this one gets stretched out, it shouldn't be white. No, but it is. So okay. Now I know what I need. I need to export this. So that's why I wanted to export it as a mask. Function output, that actually makes sense. So this is just like our UV output, and this is our mask. Okay. And now I call it mask. And now, since we have our mask, because we know the region of our UVs, we can just multiply them by that mask. And now we have it right there. Bam. And voila. Do we have some weird distortion? No. It's just a camera fisheye. Okay. Oh, it should work. Everything is local. Up. Up. And up. And now if I make it so let's generate some stuff. 512 by 512, 1024 by 1024 by 1024. Okay. Add panel. Let's look at some reference. I think in Ace Combat there was some reference. Let's check them out. Where's gather references? Okay, so I kind of want that, but can I just steal them? No, let's make our own ones. What can I do from that? Can I just make this and then just span some text with random numbers? Oh, okay. I thought I was spinning, but no. Okay, it's just the video that just like spins it. Oh, can I just? Oh yeah, can I make this corner one and like place it? Okay, that would be good. Like I place it, coordinates. Okay, that's okay. Let's make this one, and let's make some text moving. Okay, so we're gonna go in Substance 3D Designer. I don't know if I'm gonna be. No, I won't be able to move the the dots around, or maybe I can, but that's completely overkill. Okay, let's go back to Sci-Fi Slash. shape, square. Blend, tag, subtract. Okay. And let's do shape again. And now I'm gonna need I'm gonna need this one and then up like that. 0.01. And this one to the same one, and then this one, and then blend them together. Up. Okay. Now I need a map. Let's get the map. World map. Okay, can I get okay region map? Okay, where can we go? Scandinavia. Okay. Can we get something? Topography. Maybe we can get. Can we get like? Can we get Google Map maybe? Topography region, or maybe not region, just like, or like maybe. Oh wait. Maybe there's like an online viewer. Topography online map. National Geologic Map Database. That must be good, right? USGS, but it's only gonna be the US. So, oh yes, that's the thing I need. Can I hide the names? Wait. Oh, I can. It doesn't change anything. Can I hide the names somewhere? What is that? Don't say anything. Okay. Oh, because it's only the US. What is that? Okay, it's gonna be only the US. Okay, that's why do they make buttons here if they just do simple stuff? They can just like place them here. What is that? 100k. Show 100k range. Oh, it's the height. No, it's not the height. What is that? Map name. If it's only US, I don't want US. I don't want problems. I don't want US. Oh my god, it's saved. That's like, oh no. Okay. Online topology map. Free topographic map. Europe. Thank you. That's all I needed. Okay, can I get the ones without the heat map? Okay, open topo map. C'est quoi? What's that? No. Cartolite. No. Esri topo? Oh my god, it's all the types of heat map. But I don't want the heat map. Land mate. I'm doing free advertisement online. Open topography, find topography, online to map. Okay, that's perfect. Block. Where did they put me? Oh, it's here. Okay. Can we have like an outline map? Okay, let's do this one. Denmark. Up. Can I hide the names? My topo? Ah. Google Terrain. Ah, oh, that's perfect, perfect. Stay like that. Okay. No, 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 no. Wait, easy. It's not boring you. Okay. Perfecto. We have our map. Okay. Now let's go on Photoshop. Paf. Wait, is there even copyrights on that? I don't even check. Don't tell anyone. Don't tell anyone. Okay. Up. Can't even see. I can't even see where I am on this map, but it's all I need. Now let's do a bit of like filtering pass. We want light blue from that, from the background behind. Up. And now we. Oh, that's a bit too. Ah, yeah. Okay. Then we do Control J. We want to blur a bit. This and then up. Nice. And now if we add, can we get the quick grid? Wait, I'm gonna get a quick grid quickly. Okay, and now if I do this, and now up, back, up. And if I do this, oh, it's too big. Okay, up, back, back, up. Tighten, and underneath this one, and maybe we can do this. No, this one. Yes, and we need light blue behind. So like here, and we're gonna need this one to be normal, and then bap, and then we need this to be darker and probably like that. Or maybe we're gonna go a little bit greener like that. Yeah, that's about it. We can write some random shit up like coordinates and stuff, but okay. Do I want more bloom? No, I think Unreal is gonna do the rest. Up. Maybe we can get a bit more contrast. Can I get more? Yeah, because here I'm losing my highlights. Like it's this one. So this is the bloom. This is that. Maybe I can do this and put them above and do. Yeah. No, I moved them around too much. I do this. It's supposed to be the same. Wait, why did it move? Ah, okay, no, that's good. Now if I do this and I do curve, modify the curve. Nice. Now it's crisp. Now, yep. And now we can do this. Okay, that's good. That's good. Okay, let's export that. Grayscale. Wow. Allez, grayscale, but we're gonna grayscale it in Substance. TGA. Hop. T. Map. texture 01 cyber. Okay. Then we do this. And I'm going to add it to the texture pool. Where is it? Okay. And now we're going to test it up in our brand new material function. Okay. Oh yeah, I can just actually call it just here. Up. Ah, hey, that works. That's okay. Okay, it's a bit crispy. I have to say it's a bit crispy. So tile, we are gonna multiply. I think we actually don't need to. We don't want to. I think it's better to build the region. Now that I think about it, I shouldn't have tile control there. I should just still have the UVs there to control the. So we can at least like do some other material function outside the material function. We just get the mask and that's it. I think that's pretty smart. UV tiling map here 1. Okay. Okay, so now it's 0 because. Okay. Okay, that's. I should do it after actually. I'm kind of. That makes sense. I should do it here, up, and here, up. Okay, now, up, yep, that works. So, if our size is 1/4, we just need to multiply it by 4. And we are gonna need an offset of 0.5, up. UV offset, up, 0.1, up. And voila. Now, if I want to scale it up bigger, actually, we will do 3.5. And since it's 3.5, maybe because we want to do a bit of like wiggling. Nah, okay, no, let's do the wiggling on the cursor because that makes sense. Up. So one problem is like if we make the region bigger, we need to connect the UV size. But yeah, maybe I should have made the min and max trigger the scale. Yeah, I can see how we can do it. Let's leave it there for the moment and check with the texture sample if we can do more stuff here. Up. We're gonna need the exact same mask. So the good thing is like since we have the mask here, we're gonna need the exact same mask for the cross. Curve. Sine wave, curve, mass function, and list. I remember there's like a website that shows a lot of like cosine and sine function. I think it's from Inigo. Equilace. Did this one? I know he made something with like sine waves. Sine wave animation. There was a list somewhere. List. I think it's from that. Mm-hmm. No, I know there was someone extremely smart that made a list of like animations and sine waves somewhere on the internet. Like this one, for example, or like this one. Like they look good. Okay, they might not work for our purpose, but I need like random, kind of half random, because we can't do completely random. Half random sine wave. Do we have that somewhere? Sine wave animation, game dev. Probably someone who made math and realistic wave simulation. No. I had this resource somewhere saved, but I can't look it up. Oh, is this one? Okay, no, this was the easing, but there's someone who made the same one for animation. I think it gives the. Oh wow! There's even a video of like the asteroid getting like moved around with the functions. Okay. Elastic easing function. Okay. Math function. Ah, interesting. Linear function, this function. Yeah, but like, can do a lerp A to B? That would make sense. I don't care about AI stuff. Oh yeah, that's basically what I need in some ways. Can actually just blend like 2 or 3 sine waves, but that might get a bit expensive. If we do that, we just like blend them together with mask between 0 and 1. I think that might be a solution. Trigonometric functions are not going to help us there. Yeah, I mean, we can do a trigonometric function, then have the inverse function, and make some animations with that. But that's gonna look weird. I'm just tunneling these sine waves. I'm just gonna do a sine wave actually. Okay, let's do the complex stuff later. If I break my head on like one thing, I'll see thing now. Might not be worth it. Okay, so we need our target reticle. Hop là. Tac. And now up, up. And actually needs the same. Yep. And now we can multiply with the same mask, and that should work. Up. Wow. Okay, I'm actually completely brain dead. Wait. Okay, my brain has been cooked. And here and there. Hello. Up. Okay, now we want to animate the motion quickly. So what we want to do is sine wave up, sine, and now we can have time, and we do multiply, append, no, append constant is and this, and we do 0.25 and I don't know 0.47, and now we do this and we do that. Multiply and voila. Oh wow, okay, that's a bit too much. 0.07 and 0.05. Ah, yes. Okay. That's still a bit too much. It's moving way too up and way too low. Okay. No. 0.15. No, what? Oh, no, wait. Wait, it's the opposite. 4. Yeah. And let's make it, I don't know, orange. Vector 3. Let's say in the same style. Let's put anything in the color that we need. Okay. Maybe a bit darker. Ta-da! And now what we can do is have that mask our opacity stuff. Up. Maybe I can also scale from center and put the center position after. Let's organize this a bit. So this is gonna be our sine animation function to build later, because I don't feel like working on sine functions right now. This is like our reticle, and this is like our map, and that should be good. Yeah. Oh yeah, I forgot about it. Oh wait, yeah, that's what I thought. My headset turned off. Okay, I was just checking the sound was working. Yeah, there's all this stuff. I talked about it in my previous videos. This guy has like a den of like knowledge that's incredibly big. I'm just gonna put it on screen. Yeah, there's the book of shaders, but this guy carried all my knowledge from shaders. And like he has like so much stuff that you can learn from. And there's also cat-like coding. This guy is incredibly strong in graphics programming, and same like these ones. Like basically, it's the color curve atlas, and he also makes YouTube. Like everything I know is from him in cat-like coding and Priya Olmer. All these people, they make very good content on graphics programming. I'm mostly in all my knowledge. I'm mostly reusing it, and it's just and what I learned from them is like everything's basically just math. Every motion you see on screen, every color, every function, it's like everything is driven by math. So if you want to do like material, do VFX, it's very important that you understand the tool that you have, and it's not about like multiplying and tiling stuff. It's about everything else too. But you can also be very fine without touching anything of that. You can just do VFX that are way more artistic sided with like timing, motion, but mixing both is gonna save you a lot of time. And when there's bugs or stuff that you can't do with just like sprites, at one point you're gonna hit a wall, or you're gonna have to do it manually. Sometimes when I work, I see some people doing everything manually, and then when they have to change something, it's panic on the boat. It's like either you're gonna have to do it and change it for him, or everything's gonna be retaken from scratch, and that's like basically you're working twice every time there's a retake. So if you can find a solution that's like dynamic, it's gonna be way easier for you to change it. Okay, so now let's check if we can do maybe text panel quickly. Up. Text panel. Maybe I can check. I think it's in Mass Effect. Mass Effect, there's some text panel. Maybe you can just reuse the ones from Ace Combat. No, yeah, let's reuse the reference I have. So what can we do from that? Okay, so we do have some interesting stuff being displayed. Yeah, we can also animate the mask. That's true. How does that work? This one. I'm just watching this one in the corner. Like this one. Let's check quickly. Okay, it's just a scaling box that's masking the data. Nothing's spawning dynamically. Okay, this one looks like. Is it actually a flipbook? But I know this is a pre-baked cinematic. Like It's probably done in After Effects or something. Basically made this same counter with the bullets of the gun. It's pretty easy to do. What can I do? This here. Can we go a bit faster, maybe? Do we have scrolling data? Oh yeah, okay. Let's do this actually. Let's do this panel and up. Let's call it map. And let's call it data panel. From that we are gonna do. Do I have a font that's like? Oh yeah, I have this. I think I had some fonts. Wait, what is this one? Oh, it's the it's the Marvel one. Okay, yeah. I did the fan art of like Marvel Snap last time. This one maybe. Or your new type of thing is that? Like it's a very polygonal one. Is there one that I have? This one maybe? What does it say? Confirming encryption. Oh, it's all caps actually. Confirming. Oh, that's not bad, not bad. Okay. 10. Let's do this. 16. 36. Okay. Let's check this one. Up, up, up. Let's have a dark background so we can see something from that. Confirming encryption. Okay, path. It's gonna be way, way, way smaller. Up. Okay. Let's so we need a bar like that. Maybe we can just pick it up right here and do, you know, one trick I like, it's doing this and that. And now you can copy from Substance. Oh, like it's been a while we can do that. But you can copy directly from Substance Designer, get your shape directly in the Photoshop. I wish we could do it in Substance Designer, like control, like a node that's like copy to clipboard to Substance Designer. That would be game breaking. Because if you can copy from Substance Designer to Photoshop, I believe there should be a way to copy from Photoshop to Substance Designer, but that's not the case. What type of? It's a bit round. You know. How is it animated? It's like a big text. Okay. Okay, I see. We are just gonna write gibberish, and that's gonna be painful, but we're gonna do it 6. Yeah. Okay. So it's supposed to be like an encryption. Oh, okay. Maybe I'm not gonna use these things. Okay. Is that gibberish enough? I think so. Okay, does that look encrypted? Maybe I wrote. I apologize in advance if I wrote I wrote something rude, the encrypted away. I hope I didn't have offended anyone in the encryption community. Up. There a way to invert the letters or like randomize the letters and shuffle them? Oh wait, maybe there's a generator online of like gibberish generator. Oh yeah. I never thought that this would be satisfying to do. Up. Oh, let's do 5 or 6 and then let's copy them over. Up. Or maybe I can just do this, like, and do this. Like right in the middle. Oh yeah, that's actually working. Unbelievable. And now if we do this and we do this, oh yeah, that's an entire whole sentence. Okay. Oh my god, their tool. It's so broken. Là, okay. Now we're gonna just copy them over. Control J. Up. Control J. So now what we want to do is probably get the mask out of this. Wait. Yeah, actually, wait. I'm gonna do something. So we can actually pan the text too, and like make it look like it's animated without having to randomize it. So let's do that. Achum. Up. Let's get back this on the right. So what we're gonna do is build a mask from that. Up. Mouse. Up. Let's make sure. Maybe. Okay, not dumb. Wait. I'm never using the correct tools. Up. And now we can do this. Do that. And now we're just gonna delete anything that's not in the mask. Up. Maybe we can have different length actually. Never mind. I think moving the text is gonna be enough. I'm just gonna store this in the alpha or something, and then we're gonna be able to do it. Up. But now I'm gonna need to do all the entire line, I think, if I want to pan it like that. But that shouldn't be a problem. And this should be correctly. It's almost already the correct size. Now we merge them together. Pop, up. Mask. Alpha. Okay. And do we add another animated stuff? Oh yeah. Okay, I know. What I can do is do something like that. Can I have like a square brush somewhere? Do I have that? I think I have that. No, I don't have a square brush. I have this. Oh, but that's wet, wet blending for painting. New brush. New brush. Where do we make a new brush again? This? New brush. No. Wait. Where is that? It's here. Brushes, smoothing, brush tip shape. I don't have a square one. Wait, where do I get brush tip shape brushes? How do I make a new one? Do I have to just do this and type cube brush? Okay, this is my cube brush. And now, okay, it was in the corner here. Wow, they can just type new brush here. And okay, how do I change? I remember watching a tutorial about it, and I remember it was painful to do it. How can I do that? I think I can, if I remember, I can just take this, do this. It's like I do a copy, and then I do a new one, new, and I do 1024 by 2024. Do this. I do this. No, wait, I even delete it, I think. But, oh yeah, I can't have 0 layers, that's so dumb. This, and now this. I just need a quick square wash. So I'm gonna build it myself. I think you need to save it as a PSB. Okay, save as a copy. Photoshop. Wait, PSB. No. Wait. Okay, let's check. Let's learn something. How to make brush Photoshop. Isolate or draw your design on a white background, ensuring it's pure black. Go to Edit, define brush preset, name your brush, and click OK. Draw your design. Okay. Shape, texture, image. Okay. Convert to black and white. Control Shift plus U. Okay. Okay. Control Shift plus U. That's not what it does. Okay, I'm just gonna do it here then. Mode, grayscale. Up. Discard. Grayscale. Okay. Convert to black and white. Okay, that's not. Invert the image. Quoi? Brush should be pure black. Ok. 4 reçu. Reçu, Gemini. Elle est reçu. Pure black. Invert. If it's bullshit, I'm gonna be very mad. Wait, so I need to technically merge layers? Invert? It should be like that. That doesn't make sense. Okay. Invert the image. Pure black with quoi? Pure black becomes opaque. White becomes completely transparent. Okay. Define the brush. Use the rectangular marquee tool. Define brush preset. Quoi, 10? Should use this? What? Get the image. Define the... Use the rectangular marquee. Edit. Define brush preset. No, wait. Okay. Edit. Edit. Define brush preset. Sample brush 1. Brush square. I just need a square, so. Okay. Like that. Like that. Oh, that works. Oh, perfect. Okay, now I can. Up. Perfect. We just made the square brush. Woohoo! Okay. It's working. Now we have this. And now we do lines, like random lines. Up. White. Up. Oh. Wait, can I change the flow? Yes. Hardness. Oh, I can't change the hardness. This up. Oh wait, okay. No, but I'm so dumb. Okay, this is outside the mask, but when we are going to pan it, it's going to be like we're gonna use a step panning. Okay. No, sometimes it's not gonna be perfect because in Ace Combat they use AI. That's the whole topic of like of Ace Combat is like enemies like the enemy fighters they start to use AI drones. So maybe they're like their software is also made by AI. It's gonna be a bit bullshit. Okay. To work. Animated mask 01 mask alpha. Yes, so this is the alpha. What's that? I don't know what's that. I'm just gonna wait. No, okay. I know what it is. Okay. This the text. Oh, okay. Now the text I need to complete the lines. So let's just do there's a lot of like does this. The encryption is a bit broken. They use combination of A and D because they're a bit lazy. And I guess I'm gonna need a bit more. What? Oh, it didn't select the... What? Wait, what's happening? Ah, it's because there's two... This one. Whoop. Okay, maybe the software is broken, but not this much. Okay. Oh, we're gonna... I'm kind of dumb. Should have done... Control Z. Control Z. Okay, let's see this one. And let's take all the text. Ah. Isn't that all the text? Oh, okay. All the texts. And then move them to the side. Yeah. And now we can add gibberish everywhere. Up. Up. I'm gonna play a bit with the negative space so the text make a bit of sense sometimes. Up. Escape. Should have made an entire noise of, out of that. Up. Okay. Now let's merge everything together. Yes. Merge everything. Copy. Paste. Whoop. Why is this even moving? Let's just make sure that everything is covered in black. Can I log this one up? Yes. This one again. Okay. So if we need a bigger one, we can have like, or like if we need an actual noise, that's like this, you know, we can have it up. This is gonna be our text. Why is that? Okay, we can delete that. Mask alpha. Okay. And if we want, we can just like cut it a bit shorter. So the text shorter would be like here. And then we can just like have some disparities. So we will only show the letters that we want, basically, on the condition that every letter is the same size, which here you might have a bit of a cut, but from far, that's not visible. If it's for something very small, if it's for gameplay and you need to read it, well, make it cleaner. Make it cleaner and yeah, don't use use auto-generated text. Last time, wait, I think it was on LinkedIn. Last time, I saw. I think it's a localization company on. Was it Pragmata? I don't know if it's Pragmata. No, maybe it's not Pragmata. But I know it was a sci-fi game, and in the sci-fi game there was hey, here's your resume about this corporation, this sci-fi corporation, and then it starts to write like the resume. And, it's kind of it's kind of funny that no one ever read it. Or maybe someone didn't want it to double read it because he's not paid enough or something. He's like, nah, I had enough of this bullshit. But yeah, there's probably also a shit ton of text because in games, you should see like the the localization files, how big they are with all the text, especially if you have a narration game or like heavy, like an intense translation based one where you have a lot of text everywhere. That can happen. But I'd rather have like I think I'd rather have a placeholder text being displayed than hey, here's your fancy sci-fi corporation resume. So back to this thing. I need this here, and then I probably need to build a panel really quickly. Panel sci-fi UI. Can we use something like that? There's so many AI references. 5 years ago, when when AI didn't existed, there was so many references that came from games, that came from movies. Usually, you typed panel sci-fi UI, and you had the Iron Man, the Iron Man reference with Tony Stark in his suit. But nowadays, you get AI generated pack, and that's a bit sad. Wait, this one. This one would work. Wait, how is this one in Ace Combat? Oh, there's like this small stuff. Yeah, it's like there's this very tiny stuff. Okay. Maybe I should just put it on one screen, and like not like overdo it because the logic is there. Yeah, maybe I should do that. Maybe. Yeah, let's just have the logic ready, and we can make it fancier later, or like you can use it, make it fancy in production. I still need that, I think, for the map, right? Maybe I should have put it in the actual map because this square doesn't move. Now that I think about it, yeah, okay. Can I just re-export the stuff? Yep. And I need this, and I need to copy it and paste it. Up. Up. Okay, I'm just gonna do this. 42 blue. And do clipping mask. Up. Yep, like that. And maybe change a bit the color. Darker blue. Yeah, and up. Maybe like that. That. Yeah. Let's re-export it. Save as a copy. TGA, Cybermap texture. Let's go up. Now we can re-hide our map. And now we have to do some smart exports. Okay. So this one. Is there any other text that I want to put in? No. Nothing else I want to put. So this one doesn't move. So let's save it here. Let's save it in a red channel. Cyber text animation 01. Okay. So this, it's done. Now the text. Wait, maybe I can also, if I ever need a full noise of like gibberish text, at least I have it. Okay. TGA. Cyber target reticle. Text animation 02. Okay. Can't save here. Ah. Okay. It's forbidden to save, guys. Ooh. Text animation. Okay. And now I need my mask and my animated mask. Can I do this? Animated mask 3. I'm literally asking to save on like the on like the disk, and it says nope, you can't save here because it's not the same disk that I'm using. I don't know why it's doing that. And then we need the last one. This. And this is gonna be our fake like blanked out work, like censored. Redacted, yeah, redacted, that's the term. That's this one, 04. And we're done. Bam. Okay. Now we get all our textures and we combine them in an RGBA texture. We're just gonna pack them. RGBA pack. Wait, RGB. RGB. My software is broken. RGB. RGB, ah merde. Wait. Wait, is that RGB? Wait, he wasn't. Wait, he wasn't there. I checked the replay. I'm getting scammed by. Oh my god. Grayscale. Okay, maybe this in the green, this in the alpha, this as the noise. Oh wow. I think I actually seen this type of texture before. Okay, I think we're good. T text animation 01 cyber. Up, and now we can save it, put it in our files, do that, save. Okay. Oh, you know what? I think I should put just a plane here. Let's not just put an effect, because actually you don't need to load it in an effect. You can load it in an effect or an IR, but I don't think it's necessary. It's just gonna be like a material you assign to an object on material IDs. So maybe I can. Oh, maybe I can do that. Yeah. Can I get my? I'm gonna to reload the layouts. Yes, I need a plane. Up. Voilà, tac. We scale it 5, 5, 5. And up, up. Okay, and now we get our material, which is there. Up. Voilà. Oh, I need to reload the texture real quick. Voilà. Oh, maybe cyan was good. That's correct. That's okay. I'm just gonna multiply by 5 density. Yeah, so it's a bit visible from somewhere. Yeah, I really need to fix this this animation. Okay, so we have our first block. I'm gonna put the material on the right here. So basically, for every region, you're gonna want to put this region stuff and set parameters. Size, map, expanding. So it's more like offset map. Offset map. That's basically the panning value if we multiply it by time, but that's not what we want. And now here's like the sign animation, and up, we copy this block. And we are going to get this one, and do this UV here. Copy this one, and now we're gonna have some fun. Because here we're gonna do text HUD, and now because this is like when if I remember correctly, when you load the same texture multiple times, it's cheaper because the pixels get like since the same texture, you don't have to load it like multiple times. So doing operations on it is cheaper. I'm correct. What's unfortunate is we can't do the operation on each, so we're gonna have to copy it multiple times. Oh. So, but this one, wait. So what we want is get the mask, but for example, this green channel, we can do time, panner. Oh, we have stepping panner time. I don't know. I was gonna use that, but they can do whatever they want. Up. And now we can do this. And now if we do another mask, multiply. So here we're gonna do this. And we're gonna add it before the other multiply. Wait. Oh, my bad. Okay. Okay. What's happening here? Oh, my bad. What? Yeah, no, wait. I forgot something. Not here. Here. Huh? What? What? Why is it? Oh, there's a texture. Oh, my bad. It's like that. I was like, wait, I didn't transfer my UVs. So why is it like that way? And I'm like, oh, yeah, all right. I understand now. Now we're gonna need the same UV transform that should be here and there. And we're gonna do this and have it there. Up, up, texture coordinate, path, apply, and now we have this. Okay, we're just gonna move the mask. Oh, I forgot something. Size, text, add. Size, text, add. Yep. Let's do something like that. Yeah. Good thing is like I can do so many modules, and then you can just like pick from them, you know, and that should be good. Like it's gonna be like an effect that's gonna be one in like it's a multi effect, you know. I do one, you get 10. Up. Mm, mm, mm. So now what we want to do, like I could have actually used this same region. Because here I'm using two different slates of UVs. Oh, but no, but then the mask that's here, you want to multiply it with the mask from here. Oh, it's not the correct one. Yeah, no, it's good. Yep. And now what we want to do is to add this one. I would like to have like different coordinates for them. But let's have this one here. Add and do this one and then up. Wait, oh, it's the alpha. My bad. And I need to multiply with the mask. And now we can just multiply it with like a vector float or like vector 3, sorry. Up, 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 blue, something like that. Stack, multiply. We are getting some. Where is that coming from? Oh, it's coming from the. Pretty sure it's coming from the UV mask. Like this mask has like probably some issues. Honestly, that's fixable by. So if you wouldn't need to change anything in the mesh. How long is at the time? Sometimes you can have artifact when you use the truncate with the time. Oh, it's kinda funny. Okay, I want to do a last one because now that we have this, I didn't. I did not use the encryption thing. Wait, can I add it just like now, like that? So where is it now? Not even there. Oh, wait. Wait, I made a mistake somewhere. Okay, so this needs to go out, but I can actually add it from here. But this one pans. I don't want it to pan. So that's why I want it from here. Okay, I understand. It's because the UVs, and that's why I should do a function that holds them, because every time you would have to do this, basically. I want to remove this, and do this. Do this, do that. Yep, that's good now. And now we have like the correct one. One thing you'll want to watch out is because we truncate, we get only 0.5 values. But now if we do add 0.25 and we do another truncate and we do this and we do lerp and we do lerp with the time that's like fractioned, I should be able to mix between this and this with the offset. No, I want to add a constant. That's gonna be 0.37. Now we do this and we do that. Everything is truncated, but the can I do this? Wait, well, no. Okay, I thought there was something broken with my. No, it's the same ones. I'm gonna have to build something more rigid. Oh, I need to. Okay, no. Divide by 4. No, wait, the time I should divide by 4 and step it like that. Wait. No, it's gonna be the same. How do I wait? I need to say 4 time position. Can actually not use the time. Use a 3 lerp. It's the problem of using time. There should be like random time per particle random per instance random. There should be random time per tick, random value per tick. Can I get engine time? No, okay. Because that would be much easier. What if I sign this one? Then I will make it random. Okay, I need to assign both. That starts to get expensive. No? I think I'm hallucinating some math right now. This one doesn't move. 0, 1, 0, 1, 0. Ah, okay. Because I should use an odd number. Or else it's not gonna. Three. Or else it's not gonna be offset. And not step by 1, but by 0.25. It's the same. 12. Because it's the same time. 1.5. Oh, but no, this one is not truncated. No! Oh no! No, no, okay. I'm actually dumb. Because the speed is here. My bad. My absolute bad. Wait. So it's this one that I should put here. Yeah, but of course I'm returning like 0 decimals. Because it's right. So I need to do this and this. Okay, I'm getting something. But it's gonna be 0 and 1. Yeah. Okay, I'm doing something very bullshit right now. Because I need the speed to vary. Can I do this and then do this? Yes, but like truncate and do this and do this. Okay. I modify the period by 0.12, 0.01. Oh, okay. I did the wrong truncate. Truncate. Yeah. Now it's not gonna move, of course. No, it's still the same. No, I think it's because I'm using a truncate. Because the time is always set on like, because since we're moving between 0 and 1, yeah. Since I'm moving between 0 and 1, I'm always going to get 0.5 offset at like the time 1. So I need to find something. A problem for another day, I think. Oh, wait. Oh yeah, it's the same one. I didn't check. Text add. Text add. Styling. Let's make like a stonk one, like a graph. Make something like that. Let's do something like that. And let's do this. Could actually make it procedurally in shader, now that I think about it. Let's get back that grid again. Up, up, up. Oh my god, it's so low res. Thank you for the good luck message. Hop là. Should be this. Wait, did I? Oh, okay, now it's good. Now we have the stats. What else can we do? Oh, I know. Let's have numbers. Wait, we can do texts. And we're gonna make an atlas. So we're gonna do, I don't know, like 30. Oh, 32. Wait, not working. 32, 16, 60 of 8, 12. Something like that. And do this. I hope it's fitting. I think it's gonna work. Wait, let's transform it. Maybe you can have like random name. Oh, wait. Oh yeah, we remove the tiling. Up, up. Yep, that should be good. Oh no, okay, I just realized my mind is set to think with power of 2. So it put let's put numbers that are like oh no, wait. No one saw that. Okay. 6, 7. We will have the power of the 6, 7 on the stream. Oh yeah, maybe imagine if we can just now that I think about it, like we have kind of like I try to keep it segmented in the same way. The way it goes down, we can make it become red. That may be too much. No, but I'm just gonna use this, do that, put our number atlas. Okay. Yeah, but actually it's in Substance Designer, so I don't need this. So this is gonna be a channel. T. I can do that. Grid. I'm just gonna name it grid. Huh? Cyber animation grid. It's gonna be our red channel. This and that disappears. Now this is what we're gonna animate. Save us a copy. A graph. Graph animation. Basically, so okay, it's just for the clip moment of like explaining. Because I'm gonna try to like have the I'm gonna keep the replays of the streams every time. I'm gonna like shrink them down. So I'm just gonna like cut them. basically, anytime you're gonna have to have animation, you're gonna have to think about what's gonna be animated and what's not going to be animated. Anything that's not going to be animated, you try to keep them in one channel. Anything animated, that's why you want to split them in separate channel, depending on the type of animation you want. If you can try to keep them in the same RGB layer, that's where, like RGB channel, that's where you want to split them separately. So for example, our text, we had it panning each time, like step by step. And then we have the alpha masks that we also had otherwise. And then we had the redacted, which also needs to be randomized. So this is like where we need to split up in our sheets. So the numbers here are going to be like a flipbook that I'm going to like randomize. You can actually put like 60 of them, but there's no point in that. And this is like an animation, but both elements have separate animation. So whenever you have a different animation, that's like important. You want to split them up. There's also one thing we can do. Since this one is going to be a pretty low res texture, if it was only one panel, and like if it was like on a small screen, you can also flipbook it out and make it in After Effects, Illustrator, Photoshop, any software where you can make your texture. So basically, you can just like, for example, let's. Oh yeah, because I'm in the saving screen. Okay, let's try to quickly get out of here. For example, this. I would need this, and then up. Can I move? Yeah, can I move you? Yes. Okay, I'm actually not entirely accurate, but like I would just like have this one in one position, and then this one in another position. Okay, when I want to select both, it doesn't work. Okay, I would have this in another position, then this, then that, then this, then that, then this, then that, and etc. So you can build your own animation already without the shaders if you want to keep it simple, because flipbooks, it's way easier to work with them, so you don't have to do all this math I'm doing. But yeah, if you need like more dynamic elements, because I don't know, it's a bigger game that needs to have like more small interactions, then yeah, you can definitely do that, as long as the game you're working on has the budget. And yeah, that's pretty much it. Did I bake everything out from Photoshop? Yeah, the grid, the lines, the numbers, they're already there, so we can just like sort everything out. I could have just done that actually, yeah. I forget that we can just import it like that. Oh my god. Wait, can I tick? No, there's no, I swear. Adobe software that don't have like some UX elements are very missing on like some tools. Like the import tools, wait, can you? None. It's okay. Never mind me. Okay, so now we do RGB merge. This and that. This and that. This and that. This and that. And then I'm just gonna replace it, right? Can I do that? Yeah, I can do that. It's actually the same principle every time. T VFX Cyber Graph Animation. I don't know if I can start the. I'm gonna stream until like 8 or something, something around that. I don't know if. Wait, no, I re-imported it. Oh my god. I don't know if I'm gonna have the time to start this one. I should be able to start it like right now. Just gonna do like this third example and probably like rescale it a bit so you know it's a bit bigger so we understand quickly what it is. Up. So add region tests, region text. Yo, ça va, ouais, bah ouais, ça va, écoute. Hein. What's up, what's up, what's up? And up. And now we're gonna do this with the region, another one. Yeah, I guess so. I can just import the texture. Hop, I copy the parameters from here. Up. Size text, add graph. Graph. And now we are going to put it here. So, okay, two things. I'm gonna use the Flipbook node. Can I use mine? Wait, I don't remember. This one? Yeah, this one's mine. But I remember. Oh yeah, okay. This one is with the texture blending between frames. I actually don't want that, so I'm just gonna use the regular Flipbook. Up. And this, I already copied it. We want UV. We want the mask. Multiply. Wait, which one do we want here? I think we want the entire graph. Yeah. We don't want the red channel. We want this one and probably the blue one is not going to move. That's a bit problematic because I have the grid, but I don't want I don't want to like use too many texture samples, but should be fine. This one on the red channel, UV, and then we do constant. We do time, and we need to divide the time by 4. And we need to I know it's that's why. Okay. I made the mistake. No, instead of truncate, I should use step. Wait, I think I should use step. Wait, let's check. And then this. And then we should be good. Can I change? Wait. Okay, I'm gonna just debug it quickly. Da-da-da. Okay, that's a big one. I need the exact same mask for this one though. Okay. Oh, it's always gonna be this. Yeah, but then it's gonna be fucked up, right? Ah no, not that much. Now I need to scale it with the logic from here. Okay, I'm just gonna scale the graph a bit bigger. And this, no, which one was it? It's this one. Up. And we want it on one, up, up. And we want to get our mask, which is gonna be this one. Multiply. Okay, now I have a problem because the flipbook should arrive before the rescaling or after. Oh no, but it's completely unplugged now. My bad. Up. Wait. No, wait. Up. Up. Now it should be almost. Okay, that's where my logic needs to be cleaner. If I transform these UVs. Oh, but yeah. Okay. Now, this one should arrive here before getting masked out because it's the first one we want. Since it's gonna, we're already determining the UVs we want, so we want them here, and then we want them to be scaled up or down. Okay, so far so good. And now we need const, and it's a 2 by 2. Okay. Mais encore. Ah, because I'm scaling it up here. And it should be from the UV center. I'm correct. Nope, I'm not. Oh, no, wait. I forgot to rename the parameters, so that's why it's breaking everything. UV tiling graph and UV offset graph. Okay, so why is it fucked up? So if I do this, my UVs goes here from 0 to 1. Then there's a flipbook that's dividing the UV into 4 sheets of 0 to 1 UV normalized. And then this 0 to 1 UV is normalized. I mask them, and that's the problem. But I'm rescaling them. Wait, actually, I can make it smarter, so I don't need the flipbook logic. I can just move them 0.25 by 0.25, depending on the amount. And so I don't need this. That's actually quite smarter. That would be way better if it worked, the flipbook. Okay, so if it's sticking, I think it's sticking 4 times, or like, I think it's sticking 4 times. So we see it once, and it's like 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4. Okay, that's that. So if we do this now, it should be, or maybe it's just 1, 2. Ah, because there's an offset. Ah, okay, we are much closer, somewhere like here. 28, 28. Oh no, maybe it's just 1, 2 then. 28, 28. So since it's 1/4, it should be 0.25. 0.25. And maybe offset should be 0. Okay, there's another problem. Okay, there's something. Okay, if I do this, if I remove the flipbook logic, I should be able to get it right. No, I need a better approach to, because this location, I should export the position of the center, so I can then apply it to the center of my target. Wait, why did it why did it change? Oh no, 6, 7, okay, and it's only this. And so 4 times gives me, and if I do 4 times and 0, gives me the correct one, almost. Yeah, but this one, does that change the... Oh, okay. Okay, there's something in my math that's wrong, because my min and max is also moving because I'm rescaling. Since I'm rescaling the bounds, and here I'm subtracting, then I get a new center. And because I get a new center, when I rescale it, it's moving. That shouldn't be the case. Mm-hmm. Okay, big brain move. Like if I do this and I do this, it's a 2x2. So wait, so if I do, we're just gonna check here. Yeah, okay, so the UVs work here. Now, what's happening there? Oh yeah, that's exactly the problem I was talking about. Yeah, okay. Because we get 1/4 of like the flipbook UVs, the 3 others are masked and we can't see it. And that's problematic. So actually, the problem I was talking about earlier this stream where this is like we manually rescale. So here is like our manual. Yeah, here is our manual rescale for this. But that's not the correct way to do it. So basically, the problem is that since now these are out of like the bounds of the mask, to get the like one number to display, it's not gonna work because we need like the actual size of the UV that fits in the one-on-one mask. Or else we're just gonna have like the bugged version where we just get one frame and the three others are masked because they are masked from the mask region. And since I'm rescaling the tile, basically, I thought that it was the entire tile, but actually our mask, I mean, we can just see it when we do that. Like this explains everything. Wait, I linked the incorrect one. This explains everything almost. Like we get our mask here, and then the flipbook is in here, but scaled manually. So basically, if we scale a flipbook, we're gonna get the incorrect size playing. So it's gonna be the wrong position. So we need to put in this flipbook the correct position, and I thought by doing this it would work, but apparently not. Yeah, I'm feeding myself. And we need to do this. I thought that this was the solution. It's not. But it's not. It's not the solution, apparently. So this doesn't display anything, or well, if we get back to this one. Okay, so let's move this one then. Whoop, I moved the incorrect one. Let's move this one. Okay, so why doesn't it move? Because this one should be flip booked. Or maybe it's because it should be 16? Yep. Because it's the same one that goes there. Multiply, and then we're gonna do 0.2. And then almost. There's something that's it should be just one now. Oh, okay. So if I do this, wait, it doesn't move anymore. Wait, why? If it's a round number, it doesn't move. Ah, no, it does. What? I don't understand. I don't understand what I'm doing right now. Wait, why 8 doesn't move? Oh, because it's the same, this exact spacing as the step. That's why. If I do 0.25, then it should move again. No, not at all. What? Because it's depending of this? Because this breaks my UVs? Maybe just for this one, I don't actually need the region. I just need the mask technically. And scale it to the correct position. Yeah. Okay. Let's problem for another day, because now I think I understood the problem. It comes from the material function. Because basically what we have, and that's the mistake that originates, is the mistake from the entire node channel. So the mistake is the following: we have a non-normalized UV space being output from the output UV. So basically, we don't have the 0 to 1 bounds, but we have a mask that has like a position. It's taking the it's masking out the rest of the UV positions, and we don't normalize it back here. So this is not a 0 to 1 space. This is 0.25 to 0.46 or something, and like it's and it should be normalized. And right now we don't have that, so I need to rebuild it. And I think after rebuilding that, our UV will work. Okay. Right now, I don't feel like painting it, honestly. I just have like what are these 3 hours? Yeah, I'm 3 hours into thinking this. Let's forget about that red channel. Okay, let's build it later when I get a fresh mind. And yeah, as usual, region UV. So we're gonna just build it from the blue. We're just gonna add this one, and we're gonna add this one, and we're gonna add this one. Too bad for the 6-7. I wish we had the 6-7 with us, but it's not gonna be there today. It's broken. I'm gonna repair the 6-7. So this in here, this in here, and this in here, and up. Okay, so it should be 4. And where do we get our graph from? This one? It should be here also. Up. Oh yeah, it's 0.5. And now what we can do is use the same stuff. So we're not going to use it here. We're going to use it here again. UV time truncate. And we're going to divide it by 4. And we're going to do it here. And now it's going to move. Wait. Component mask. No, wait. It's already a single float. Append. Append. Vector. This is here. This is constant. And this is 0. Now that works. I'm getting trolled by my brain. Okay, so if this append add, yeah. Append X value. Because I rotated the plane. Yeah, woo! That works. Woohoo! I remember the plane is rotated 90 degrees. And now that works. Perfect. Voila. And now we have our animated graph. Ooh. Can actually make an AKG if you want. You just remove the truncate. You have a mask here, and then you can have toot, and then you can have like the BPM somewhere. There's always like a way to build it, kinda. Like the animation is just how you're gonna put your panning together, how you're gonna put your textures, your channel, make it the smart way. I'm probably gonna build other modules, like smaller modules here, there, so we can have it tight. I'm gonna probably make remake this same function, but I wanted to start this one. I wanted to start this one today, so we can have like we can have something you know, something working on that. Let's make a small scene of like boxes first. Let's build like relief, you know, like some fake mountains. So for this one, I thought about the effect of Death Stranding, while you know he's scanning the area, and depending of like the difference of height of like the simulation position, it would adapt the, you know, the location, the type of like UI element that's displayed. So wait, Death Stranding scan. Oh, actually, someone has already remade it, but yeah, basically that's the idea. It's like to rebuild this this logic. I tried recreating the Death Stranding effect. Okay, apparently I'm not the only one. Well, yeah, what you want to do is basically get your character location, which is gonna be attached to our character, probably at the root. We are gonna spawn a grid because that's how it works. You know, we have a grid, and each point or each particle is gonna get its height location based on the distance field. Probably, I assume it's distance field. So then any non-dynamic actors, or like non-movable actors, if we are in Unreal Engine, we can get their height. And I don't know if they do it also on animated actors, because since they have a custom engine, they might be able to do it. We can probably add some extra stuff on this scan as well, like have the like highlight some items with stencils, do some stuff like that. Yeah, and like anytime it's steep, you know, it's like dangerous for the character, and you might lose balance. I kind of like this effect of like having like some dots. So how to build that? Simple. It's very simple because Unreal has built tools for us to make it. We're gonna reuse this tech from I think it's here. Yeah. Basically, here we already sampled some points on the distance field. but these are like random points in a location, like in a radius, basically. So here I have my radius, and it's like it's taking a sphere. We can actually see the. Can we see the end, or like did I do it so it's visible? Okay, I think I did it so the radius covered entirely. Maybe we can see. Let's go in wireframe. Yeah. So yeah, actually we can see the radius now. So here the radius. It's gonna. Here it's taking any points in the radius, but if we add a grid location, each particle will place itself on the objects, but also taking the grid location as an input. So I think we're going to use that. And that should work. And then we can take the particle height compared to the simulation space, or like the simulation location. And then we would be able to determine if it's too steep or not. What we can do is use the same logic as like Boyd's simulation. When you use a grid, you have to know that you can get your neighbor's cell value. By doing so, if you know your neighbor's height, you can determine for each particle the angle and if it's too steep or not. So we're gonna use Photoshop to draw a bit of like you know, stuff. So let's say we have particle 1, particle 2, and then we draw our topology like that. What we can get from this grid, let's say it's like a one grid basically, like it's a one line grid. It means that each neighbor can know the value of the next one, because basically we have our index. And when you do a grid, when you initialize a grid, you have the index. You know, it's going to be 1, 2, 3, 4, 5, etc. And if we know the index, we can then get its position based on the index. And if we know the position based on the index, that means we can do position index 1 minus position index 2. So then we get a direction, like a vector. You know, we get this, which then can give us the angle. I call it theta, but you know, it's like our angle. Maybe I'm gonna use another one. That means we can get the angle. If we get our angle, that means that we can determine how steep based on a threshold. So we can have like you know, we can have like a steep factor, you know. And if the angle is higher than I don't know, like let's say 15, then the particle, we set particle color to you know, I don't know, green. So basically what we have is like let's say it's blue and it's low, you know. So these two might be blue, this one might be orange, and this one will be red. I like how I said green, but I actually put blue. Okay, this one will be blue, this one will be blue, this one will be blue, and this one will be red. Or maybe, okay, let's put this one red. Now, based on our character location, which I'm gonna put in pink, let's say our character is, so for this to be correct, our character is here. Okay? So this is the data when the character is here. So here it's pretty close, here it's pretty close. So if you, for example, jump from here to here, it should be correct, you know. And the scan only happens once, so the data is not updated. I think it's not updated in real time. I'm not sure. But so if your character moves, then the particle system attached to it will change its data. So now let's say you're here. Now this one would become green because it's at your height level, basically. You're like, oh, well, it's my height. So, and because this one is unreachable because of the angle, then this one is red, 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 this one is red. Or maybe we can actually just make it blue again. But these two are too steep, and this one might stay. This one might stay like that. You have to think that when we are at a location, all those locations are like will get green as well. But this one is red to us because the angle from our current grid position is too steep. But then this one, because it's not our closest neighbor, we can say that, okay, but these ones we are flat, so it should be safe to be on them. But since these ones are my direct neighbors, then these ones are too steep for me. We have to think about like this two-sided logic as well, because we can't just say, oh wait, everything is red above me because I can't access it. No, it shouldn't work like that. It should be, I should get all the grid points that are accessible to me and check their height, if it's too steep or not. And when it's too far, then I should also check that, oh, these neighbors together, they form a block that's like safe to walk on. And this one is like, nope, big nope. Wait, nope. This one are like big nopes. That's how I assume it to work. Kinda. So what we want to do in the engine, we're gonna go straight back here. Let's check Niagara effect, cyber, Niagara system. We have NS, cyber, grid, scan, effect. I'm gonna place it here. Okay. Just gonna, did I save everything? Nope. Okay. Any grid point system. Okay. Let's grid location, fix issue, and now we are gonna do spawn particle on grid. Are they spawning? I think they're spawning right now. Nope. Nope, they're not spawning. Okay. Okay, the grid is not local space. Spawn count, spawn time, okay. Okay, this drives the offset. Infinite is the offset per one, so we get expression. I want particles dot id dot index plus 5. And I forgot to do require persistent ID. Oh, that's pretty good. Okay, that's a lot of particles. No, okay. Yeah, let's just break vector and then do expression and then particle particles and that ID that index plus 0.5. And then let's do a bit less 0 on the Z count. Oh, that's why. And let's do copy. I forgot to do modulo. It's gonna be modulo index and it's gonna be par 5. No, wait. No, 8. Wait. It's modulo of the column normally. Wait. Wait. Break. Add particle index. Wait. Return. Normalized. Oh yeah, but forgot that the offset will not work because this one will work diagonally because I forgot how to use the grid location. Forgot to do that as well. Wait. Grid location, Unreal 5. Grid based grid location, Niagara. No. Wait. Isn't there like documentation? Wait, grid location. We're gonna just check it quickly. Well, what does it do? What does it do? Okay, it takes the count. We have count. Take the exec index. The exec index is then modulo divided by the amount of grid count y. Okay. Grid cell coordinate will get x and y z count as vector. But wait, but it's not supposed to already be like that. Oh, my bad. My bad. It's just the offset of the entire grid location I was doing. Okay, my bad. So dumb. Forgot it was here that I needed to change it. Okay, and then we do GPU distance field to surface. Alors, yes. Compile error. Query mesh distance field GPU, it's in the update. No? After the grid location? Before the grid location? Dismiss. Navigate to source. Oh my god. Okay, my madness level is slowly going up. What are they doing? Distance to surface 0. Okay, it's the initialization. If it's GPU simulation, okay, well, then I understand that. Ah, bah voilà. See, sometimes it's useful to check the code because it didn't tell me. Wait, did he actually tell me that it needed GPU simulation? Oh yeah, my bad. My bad. I just didn't read the text and I was like, oh, there was a mistake. And then I was like, I'm gonna recode the entire the entire scratch pad. Nope, not gonna happen. Okay. The thing is, we need it in the spawn. But why? Okay. And it doesn't do for each particle. It does for the entire grid. Ah, okay, now it works. Okay. No. Oh, 5000. Okay, so now we have our particles. I should put this one to, I think if I remember, if I put them to static. No, it's static already. Okay, I can't see anything. I'm just gonna place this one, place this one. It's like, it's like basalt rocks, Okay. Then I do this. Okay, it's not taking the height. I think I need to max trace distance. I need to raise it up. If I do force, it's gonna force them. Yeah, force them out. Obstacle avoidance strength. Can we? What happens if we crank it up? Nothing because it's strength. And this do nothing. Okay. This one makes it so. Now this one is avoid distance, but I think there's like distance. Ah, my bad. Wrong module. Ah. Now we're talking. Okay. um. Oh. See? Oh, since it's taking the distance field, you can't do it too far. So if I do 50 by 50. Oh yeah, but no, okay. My bad. Okay, I see. Okay. I'll use the 15 by 15 first. Okay. We need a world space grid location. Just gonna take some notes. World space grid location. So basically what we want okay, what we want for this effect, it's we want to have a world space grid location. Why? Because if my character moves, it's gonna move also the grid. Then that's probably not what we want. We want the same spacing everywhere. So if we scan multiple times, it just refreshes the data and doesn't. So basically, what we need, okay, we need a refresh input. We need to be able to refresh the input, the already living particle. Then we need the world grid, the world space grid location, because we don't want to have like points that, you know, if we respawn it or like if we refresh, we want the point to be stable. So it's like we initialize a grid on the entire world, and that makes it better. We need a height comparison neighbor system. We need to compare the height of each neighbors. That's for sure. Oopla. We need close grid, or maybe I just need to compare the neighbors since we need take in consideration the height position of the character entre parenthèses parentheses simulation space position so basically, yeah, like I just talked about before, we want our character to adapt to the position location of the simulation space. And we want our character, we want our particles to take in consideration the position in Z of our character. So we know the steepness of like the closest one. And then when it's further away, we can decide if it's too steep or not for the like in global. Because you want the ones around you to display if it's too steep or not, but you don't want the furthest one to be entirely red, because basically if the points were like way further away, you don't want them to be displayed as red, maybe. Or maybe I'm wrong. I need to rewatch some footage. Wait, can we just see it? I'm just gonna rewatch it because maybe I'm making it more complex than it actually is. Where is that? Yeah. Oh yeah, everyone has remade this mechanic. That's crazy. Oh wait. Oh yeah, yeah. Okay, look. That's this. That's what I was talking about. So okay. So let's check the article. Yeah, there's the scan lines. Okay, the silhouette. Okay. Yeah. Custom post processing. Yeah, I mean it's a distance field. Okay. Yeah, like he has it together, you know, but yeah, shallow water, etc. Blah blah blah. There's grass and everything. I know that. Oh, okay. I thought it was the area that was around the character, but no, it's actually the grid position of like where stuff is. That's probably because he's using the wrong render pipeline in Unity. Classic. Ah, okay, wait, yeah, yeah, that's the fade of the particle that it should be. No, wait, what's that? Kill angle, kill radius, larger radius. What is he doing here? What? Ah, it's water. Okay. Okay, I didn't notice that it was water. Because you know, okay, if it was completely dark behind, then I would notice. Like if it was like this, I would be, oh, it's the sea. But yeah, no, it's not. Vertex fragment outline. Uh-huh. Yeah, we have the Sobel function in Unreal too. Sishen Liu. Who is Sishen Liu? Wait, let's check. Technical artist. Oh, okay. Just to check the background of like the person who made the article. Yeah, he seems like he really looked into that. Make particle collide in Niagara. Oh, yeah, that's actually a pretty good resource as well. Niagara grid feel like super drawing location to okay. That's a decal, right? Maybe not. Yeah, this one I've seen. I've seen it in animation. I think I've made one myself too. But yeah, like this one. And what else? Yeah, terrain too steep, shallow water, very deep water. Okay, okay. That's actually very nice to have this. Getting increased level of risk. Okay. So what we can do is set, yeah, and do particle color. And what we want to do is we want to set the color based on this on its height. What if? Yeah, but because I want to do it based on the steepness. Like I think I'm overkilling. No, based on the steepness of the neighbor. If there's a difference. Oh wait, yeah. Oh no, yeah, I can do that. I can do that. If wait. Oh yeah, let's do this expression. No. Oh. Okay, so if we do this, we do particles dot position dot z superior at oh no wait if particles no engine dot simulation position minus particle position superior at 5. Wait, did I forget something? I think it's like emitter position. Simulate. Oh, it's this engine dot emitter dot simulation position. C'est pas vrai. Superior 5. Okay. What did I mess up? Niagara Rocks. Invalid format. Swizzle Z. Can't convert vector. Bool. Oh, sorry. Bool. Okay. Now it's red. Oh. Ok. Supérieur à n. Supérieur à 0. Ah no. Then it's the opposite. Because it's higher than my position. Yeah. And then superior to 1. Okay. So what if I raise it up like that and then I do 500 and do what's the maximum height? Can we do this? No. No, unfortunately, that's a bit complex. If I raise it up, it's not gonna... Okay, it's not gonna do it correctly. Unfortunately, and it's only locked here. No. Oh, it might be underneath. No, is it locked? Oh, yeah, it's underneath. So there's like a location where it's like, if I do this, it's gonna work. Yeah, but I'm gonna lose some space here. It's kind of like I need another type because it's not like the move to GPU. No, the other one, the nearest surface force, because there's like a distance trace. We don't have that. We don't have that distance trace. So if I move here, it's gonna work because it's the highest point. But then I'm gonna lose some data here, which is fine, honestly. But if it's here, yeah, we are losing this. It's not like we can be able to see it, but if I scale it in Z, does that work? No, it doesn't. Okay, this doesn't do anything. Set drift over time. To avoid drifting, you can disable off intersect position by radius. But then that doesn't work. Ah, this. Ah, okay. Then what does that do? But that then doesn't work. Ah, d'accord. Okay. Okay, I understand what then the radius is for. Okay. Never used this function before. Yeah, but then the problem is like, yeah, it doesn't detect this one. That's the problem. So we're gonna have to fix that. What was the problem here? So we get this one. If it's superior to 1. Can't we get like, no, but even if it's 0, it doesn't work. Yeah. So there's a problem with that. Oh. Still the same. So here we have the distance of particle position and simulation position. I forgot to re-put the... Time is running up. Simulation position, particle position, Z. Maybe we can, wait. Maybe for the moment. For the moment, we just do this. Oh wait, even that doesn't work? No, there's a problem then. Yeah, there's a problem because here every particle should be white. Like any particle above the simulation position should be white. That's it. Simulation position, yeah. Okay, we can do something then. Superior à no. Wait, what's the location of this one? Just to have it go. Why is it? Oh, maybe I can do this. Yeah, none of them works. That's crazy. 51. Well, time is running out anyway for today's stream, and my brain is like reaching text saturation. So I guess that's it for today. I can just quickly do a recap of what we've done today. We started to do the function with like the masking UV, so we can transform each layers individually and make like small animation for like screens. I quickly covered the effect we were doing last time and like showed a bit the spell system. I will show the spell system again. Let's check the spell system. Is blueprint spell system. And let's check the spell system again. So the spell system was the following. We have our master blueprint that drives all of them. The master blueprint then send a message through a blueprint interface to cast the spell. The cast spell is then sent to execute spell function, and then on each child we have a function that drives the behavior of the spell itself. So now I'm just going to display them. So here we have a projectile. The effect of the projectile doesn't get cleaned up because it's an infinite for the moment. We had this array system that was like, having an array radially or forward. We have this fast cast spell that just plays at the location of the spell. And we have the rain of effects with the newly implemented effects from the cyber wave, so the phase 3. So this has been implemented to work correctly. I'm probably gonna work on the different elements we've seen today off stream as usual. When it gets too technical, or like when I need some like actual research to avoid like indigestive content, I'm just like relying on like doing the complex stuff off stream so I can do the research, do trials and error, so you don't have to suffer my my absolute like the absolute nightmare it is sometimes to test some stuff in Unreal, and you don't, and also sometimes it crashes the engine. So I don't want to have like to relaunch the engine every time and start from scratch. So I'd rather have like something done, just like this one. I just started like having notes. It's way easier to like make some notes, then stream and then talk about it, because at least I know what I'm talking about. Here I'm like, I'm going in the territory of like I don't know shit about it, and I can't make something that's gonna work 100% directly. And to me, it sounds like it would be unwatchable. But that's it. That's it for today. Thanks for joining. Thanks for the people who joined today, and I see you next time in stream. I haven't scheduled anything yet. It's usually gonna be in the weekend. Can be randomly during the week, depending on like my workload. This week might be lighter for me in terms of like schedule, but I never know in advance. But yeah, just subscribe, click the bell button so you get notified. That's the only thing, the only tips I can tell you, because YouTube YouTube is weird space to be streaming on. But that's a very nice space to be actually, because I think it's way easier than Twitch, honestly. That's it for today. See you next time. Have a nice rest of the weekend while I'm trying to solve these problems with like shaders and HLSL. Have a nice one.